Okay, here this is a matrix. This is a square matrix, and this square matrix this is a 5x5 matrix. And how we can index, how to specify this matrix in MATLAB. For example, if you people are interested to find which entries are which to index which entries where. So the rule is in MATLAB, or we are having a 5x5 matrix. So it will start from the left hand side 1, followed by 2, 3, 4, 5. Then the second column will start 6, 7, 8, 9, 10. And the third column will start, that will be 11, 12, 13, 14, 15, and so on, up to the last column will be 21, 22, 23, 24, 25. People are interested which element is on the 19th position, or what is the index value of the 19. So you people may write, for example, this is a matrix A. Matrix A is equal to 1, 2, 3, 4. Let me change the entries of the matrix A. 2, 4, followed by the semicolon, 6 and 8. So here on the first position, 2, second position there is a 6, and the third position is 3, and on the fourth position, or the fourth index, is 8. And if I can write A, and if I'm interested to find which element is on the third index, which element, so A3, and the answer will be 4. Similarly, it's very helpful in MATLAB. For example, let me declare another matrix, and that is equal to 1, 2, 3. Semicolon, 4, 5, 6. Semicolon, the third row will start 7, 8, and 5. So a matrix is declared here. And there is a very handy mathematical operator, that is the colon. The colon. How we can write the colon? So how the colon can help us? For example, if we people are interested to have allocate to the number of rows. How many rows in the matrix A? And if I'm interested in the first row, so I can write A parenthesis. So colon stands for the all elements, for the all rows. A is followed by the parenthesis, the small bracket, right? The left parenthesis, and the left parenthesis is followed by colon. So colon means all the rows. You will take all the rows. And if I'm interested in the second column, so I will write the second column here, colon, comma, 2. So all the entries will appear. Yes, 2, 5, 8. So column 2 is appeared here. Only column 2 is appeared. Similarly, if I'm interested to find the column 3, the entries of the column 3, so I will, and all the rows and elements of the column 3. So A parenthesis, all entries, for all entries we will use the colon, comma, 3 and 3, 6, 5. Similarly, we can also use, for example, I'm interested from row 1 to all the entries of the row 1 up to 2, and the third column is appeared. two rows and the third column appears. So 1 colon 2 comma 3 and 3 and 6 will appear. So this is how the colon can help us. Also, colon is used in the row vector as well. For example, we are having a vector x. This is a row vector, and we are starting from 1, and this is the starting point, and we are going to the end point, the end point, that is 10. So it will start from 1, it will go to the 10, and by 10, by default, the difference between the two entries will be 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is a row vector. Similarly, we can use the increment. For example, the increment between the starting and the ending point, that will be 2. So this is the start, 1 is starting, 2 is the increment. This is the difference between 2 points, 2 digits, and the end will be 10. So 1, 3, 5, 7, 9. Similarly, we can also use another command that is equal to length space. This is also a row vector, and it will create, for example, between 1 and 10, and by default between 0 and 1, this is linearly spaced elements between 0 and 1, and by default it can take 100 values from 0 to 1, and what would be all the values, all the entries will be linearly spaced. All this is column number 93 through 96, column 97 through 100. There are 100 values. Let me write the CLC. Let me clear the command window. Similarly, if I can write the length space command, the length space function, and it will start from 1, it will goes to the 10, and how many steps it will take, that is also 10. Let me write the 10. In 10 steps. Linear space elements between in 10 steps. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. With the Matlab, this is a row operation, some basic row operation, though it's important for you people in control system. We are having state space representation of the transfer function. So that's why we might have a square matrix, we might have a row matrix, we might have a column vector as well, and the multiplication of the certain matrices. Similarly, we can find the inverse of the matrix. You people know that it's a not easy task to find the matrices of the inverse of the matrix. For example, we're having that is equal to 1, 2, 3, 4, 5. Semicolon 4, 6, 7. This is 3 cross 3 matrix. 1, 2, 6, 3, 4, 5, 4, 6, 4. And if you people can use the command A followed by the apostrophe, single quote. So the transpose of this matrix will be taken. Transpose means the number of the rows will be interchanged to the columns. So how the rows are interchanged with columns. Similarly, I can write I and V inverse of the matrix A. So that will be inverse of A. So these are the inverse of the A. So this 3 cross 3 matrix is not easy to find the inverse of the matrix by using the MATLAB software. Easy for us to find the value of the matrix A. Similarly, we can find the eigenvalues EIGN, and we find the eigenvalues of the A. Yes, these are the eigenvalues of the A. So MATLAB provides us the opportunity to easily find the value of the inverse of the matrix, multiplication of the matrix, especially if the matrix size is very large. It might be 100 by 100 matrix. Okay, so this is how the row vector is 274. This is the column vector, and we are having the square matrix. The row vector is one-dimensional array. Similarly, column vector is also one-dimensional array, and we're having two-dimensional array, so that will be a matrix. So a matrix is a two-dimensional array. Basically, a matrix is a two-dimensional array. That's what we have done. We are having x is a variable. This is a row vector that will start initial value, followed by the colon and the increment colon the final value. Similarly, we have also used x that is followed by linspace length space command, length space function, start value, the end value, comma, the number, how many steps, and how many steps we can create linearly spaced elements. Also, we are having a log space function as well. It can produce logarithmically spaced row vectors. If we are interested to find the length of the matrix X, so we can also find the length of the matrix as well. There are some special matrix, zero matrix. For example, I can write a matrix having all the entries that is equal to 0. It is 5 plus 5, so 5, it will be a 0 matrix. Similarly, if the special matrix having all the entries that is equal to ones, O-N-E-S, ones, so it will appear all the entries. For the identity matrix, we can write identity, I. So I-E-Y-E, I. Identity matrix E-Y-E, 5 cross 5. We can write 5, or it might be 5 cross 5. So it's 5 plus 5. 5 plus 5. This is 5 plus 5. If you are interested to find also a rectangular identity matrix, for example, 4 comma 5. So 4 rows and 5 columns. So it will be 4 rows, 1, 2, 3, 4, and 5 columns. So we can also find the size of the matrix A as well, and some other commands. You people are familiar with this. Now, how two matrices can be added? Two matrices can only be added when their size, a size is equal. For example, this matrix can be added because their size is equal, rectangular. But these two cannot be added because their size, their dimension is different. Similarly, we can use the command random, R-A-N-D. So it's very useful command. For example, we are interested there is a variable A and R-A-N-D random. We are interested that will generate numbers between 0 and 1. This is how we can create random numbers between 2 and 5. R-A-N-D. basically two. This is the two is the or two is the number of rows and 4 is the number of columns. Here also A is equal to RAND, 2 is the number of rows and 5 is the number of columns, and it will produce some number as well. This is the dimension of the matrix, and it will randomly generate numbers. So here we have used the semicolon, and semicolon is used as a row separator. Similarly, we can use the comma for the concatenation of the two matrices. If we are having a matrix A here, and that is followed by the comma, and 2 multiplied by the matrix A, followed by semicolon, 3 multiplied by A, and followed by the comma. So this comma is used as to concatenate different matrices. Also, how we can write a column vector. For example, we are having a vector A, and that is equal to 1, 2. Inside the square brackets, we are having other square brackets 1, 2, and 1, 2 is followed by 1, 2 square bracket, and that is followed by the apostrophe, and then the comma square bracket. We are having another column vector. This is 2 and 3, and after 2 and 3, this is followed by the comma, single quote. So it will appear as 1, 2 is a one column vector, and 2, 3 is the second column vector. Okay, so this is just some basics about how we can perform some basic mathematical operation, just like multiplication, how to take the inverse of the matrix A, and how to take the, similarly we can find the determinant of the matrix as well, det of matrix A. So you can find the determinants of the matrix A, that is equal to A. Okay, we have just in the what we have discussed about the colon operator and matrices. So sometimes it can help us. For example, I'm having is a Cramer rule example, and in this example, we're having a vector that is equal to A 1 minus 1 5 8 3 12 semicolon minus 1 minus 9 2. This is a 3 cross 3 matrix, and this is a linear equation in the Cramer, just like how we can use in the Cramer rule. We are having linear equation, and that linear equation is transformed to the matrices A, B, and matrix X as well. So this is there is another matrix. This is a matrix B 5 1 3, and here this followed by the apostrophe. It means this is a column vector, and here delta determinant of A. So the determinant of the value of the matrix A is assigned to the delta. Similarly, we are having x1. What will be the value of the x1? That is the variable x2 and the variable x3. So here determinant of the matrix. This is the matrix. So B is written here. The matrix B, when we calculate the value of the x1, so we have write the column vector of B. So B followed by the matrix A. So all the entries, all the rows of the A, and only column 2. Similarly, the same A matrix, all the rows, and only the third column is here. So the first column is assigned to the B matrix, and all the entries of the second column and the third column remains the same. So there how we can find the value of the x1. Similarly, x2, the same matrix A, all the entries of the first column, all the entries of this. Here, this is the B, finding the value of the x2. So the matrix, the column matrix B will be, we can write over here, B, and afterwards all the entries of the rows and only the third column. So in x2, finding x2, column 1, afterwards the B matrix, the column matrix, and then the third column. And similarly, we can write the value of x3, first column, second column, and the matrix B. So in this way, we can calculate the values of x1, x2, and x3. So this is one of the handy application how we can find the colon operators and how we can calculate the values. So in command prompt, this is the value of the x1 is equal to minus 2.1, x2 is equal to 0.24, and x3 is 1.4877. Okay, going further, this is how the proper matrix multiplication we have studied, A cross A, and B is equal to A dot followed by the static A. So this is the element by element multiplication. So this is how we have discussed about the transpose identity matrix. This is a multidimensional array. Similarly, we are interested to find strings. So already we have discussed the strings. These are some mathematical functions: sine, cos, tangent x, and other functions: absolute x, angle of x, square root, sqrt. For square root, sqrt command is real, imaginary x, and conjugate.